B of this problem says, let S be the base of a solid whose cross-sections perpendicular to x-axis are squares. Find the volume of the solid. So this is a 3D volume problem. So we're going to do more of these later on, but we're just going to start practicing some of these 3D volume problems. So they've given us this area S, and what they're saying is that this length here, so the distance between the green line and the blue line, represents a side length of a square that's going to come out in 3 dimensions. So I'm just going to try to draw this coming out in 3 dimensions. And so we're going to have a square with this that's coming out of the page in 3 dimensions like that. And we're going to have a series of these squares popping out that give us a 3-dimensional solid in this region S. Now, since this is a calculator problem, I want to make this a little bit easier for myself to deal with on a calculator. So what I'm going to do for B is I'm going to just graph in one of the y functions. I'm going to graph the difference of the two functions. So I'm going to graph f of x minus g of x. Okay, so if you're putting this in a calculator, you're going to take that exponential function, subtract the polynomial function, and when I graph this, the graph's going to end up looking something like this. It's going to go down like this, and you're going to notice that the zeros are all in the same place as the intersection. So that's 1.0328. This is 2, and it crosses the x-axis. The y-intercept is at 0. So it's gonna, those are the same intersection points that I have up here. But now I've graphed these two graphs together, and the area is going to, between these points, is going to be the area above and below the curve. Okay, so we can see that here. So this is equivalent to R, and this is equivalent to S. Okay, so that's the first part. So if I want to write the area of that square, so to get the volume, I need to take the cross-sectional area, the shape is a square, and I'm going to give it some thickness. Okay? And I'm going to multiply by that thickness dx. And in general, and we'll go over this again later as well, but in general, volume is going to be cross-sectional area times thickness. And that's how we find volume in calculus. Okay, so I'm going to write this down. So the volume is equal to the cross-sectional area times thickness, not think, but thickness, and then we're going to sum up all those pieces. So that cross-sectional area is actually, the cross-sectional area is equal to the difference in the f of x and g of x. So it's going to be this length here. And maybe I'll color code this so you can see what's going on. So I'll do this in red. So this length here is going to be f of x minus g of x. And if I want to get the area of the square that's coming out in 3 dimensions here, it's going to be, I'm going to take that distance and square it. So that's going to give me the cross-sectional square. Okay, so if I want to find the volume then, I'm going to use an integral. So I'm going to find the total volume is going to be the integral from the lower bound to the upper bound, and it's going to be the cross-sectional area. It's going to be f of x minus g of x squared. Okay, so it's going to give me that square area in here. And then I'm going to multiply that by the thickness dx. So there's going to be some thickness dx I'm going to use. So I'm going to multiply that by dx, and I'm going to integrate all those slices from 1.03 to 2. And this will represent my this integral will give me the volume. Now, to do this easily on my calculator, what I'm going to do is I'm going to graph, in my second graph, I'm just going to graph the area. So f of x minus g of x, and I'm going to square that, and I'm going to get an area that looks like this. Okay, so when I graph that, my area, I'll go to my graphing calculator here, is basically taking the y values and squaring it, and so I end up with something that looks like this. Kind of goes up and down and up like that. Okay, and you'll notice that again, this section from, this is the 0, 1.0328 to 2, this represents the square areas. And so if I find the area underneath this, this will give me the integral of that. So this area will be equal to this volume. So then using my calculator, I'm going to use the integral function. I'm going to integrate, my lower limit is 1.0328 and my upper limit is going to be 2. And when I find that area, again, this is from my calculator, the area that I'm calculating is 1.283, 31, I'm going to round that to 2. And that's going to be units cubed, because I'm taking an area multiplying by thickness, I get volume. And so this represents the answer, that area represents the answer to this problem. Okay, so this is the area underneath the curve of this curve here, and those areas match. Okay, so the volume that of the solid that's generated is going to be 1.2832 cubic units.